Hey everybody, in this video we're going to be talking about energy efficiency or renewable energy resources. So this is our Unit 6, Chapter 16 from Living in the Environment. What we're going to go over today includes how we can improve our energy efficiency. Specifically, how do we retain energy by lowering the amount of energy that's required to do the daily tasks that we need to do. We call that resource negawatt, so a negative watt, if you will, which we'll talk about in an online module. And we'll also study some renewable resources that generate energy for us, and that includes biomass and energy that we get from biomass, including refined biofuels. We'll talk about different ways in which we can capture and use solar energy, access to the Earth's energy that it's generating itself under geothermal, hydropower, and how we can generate electricity using the flow of water. And then we'll also look at wind energy as well. So the first step to becoming a more energy efficient system, whether it's an economy, a town, a city, a country, whatever it is to lower unnecessary waste of energy. We have a very high waste economic system that's associated with our cradle to grave output or throughput in our environment. So, we access energy that is in high quality, we access matter that's in high quality, we put it through our system, and we lose a lot of that energy as waste, eventually at the end of the system as heat. And along the way, we generate a fair amount of pollution as well. So the measure of how we work to get each unit of energy used is referred to as efficiency. And so in any more sustainable plan that is out there, the foundation is always going to be energy conservation. Can we conserve the energy by just simply not needing it? And then finally, we think about energy efficiency. How can we change the objects that are around us that use the energy to do the same work, but do it with lower energy requirements? That refers to our energy efficiency. And then finally, when we do need to generate energy, can we make sure that it is a renewable resource? So it's not a resource like coal or another fossil fuel that once we use the reserves, we have depleted them entirely. We want to have energy resources that are going to perpetually be available to us. So the benefits of doing these three things are going to prolong our fossil fuel supply so that if we do need it, we can use it, reduce oil inputs and improve energy security for a particular country. And specifically the United States is often what we think about, but this is true for any country out there that wants to be independent in terms of how it creates its own energy. We want to make sure we have a high net energy yield. That's always going to be the case so that we reduce costs and are as efficient as we can be. And of course, we want to reduce the waste and pollution outputs that are associated with these energy generating practices to make sure that we have as low environmental degradation as possible. If we make changes in energy efficiency and commit to energy conservation, then we have more time for renewable energies to come online and more technologies to be developed. And throughout that, we also are going to have the ability to create more jobs. So we want to conserve energy, we want to be efficient in how we are using it, and we want to make sure we are moving towards renewable energy sources. So one practice that we're seeing used more and more is to reduce energy waste by using cogeneration. So right now in most homes in the United States, in most business practices, in most industry, etc., heating is separate from power. So where we generate our electricity and where our electricity comes from is typically separate from power. That's not necessarily the case everywhere, but in most places it is. And so we're seeing a suggestion to shift towards what we call cogeneration, or a combined heat and power project, where the two useful forms of energy that we want are produced from the same fuel source. So this is going to lead to sort of higher energy efficiency. It's nice because when we generate electrical power, often what we see wasted is heat energy. And if we can capture and use that heat energy for heating our homes or for whatever we want to use that heat for, this is a really good way to do it. So in this case, right, we have a primary fuel that comes in, maybe it's a biofuel, maybe it's a fossil fuel, whatever it is, goes into our engine. And our engine is going to use that fuel to, in some cases, generate electricity, but in some cases, generate heat. And we can make sure we absorb the either excess heat that's coming off of the engine or the heat exchanger to actually produce the heat that we need. Electricity is also going to be produced in the same way, and we can use that electricity to power our devices, whatever they may be. So this would be a really great plan to eliminate or reduce the amount of energy wasting electric motors. It allows us to recycle more materials. Other plans for making sure we reduce our energy waste include switching to high efficiency devices. That includes lighting, and it's also going to include appliances. We want a smarter grid overall so that we know when to send energy to the highest demand spots and we're not wasting the energy being sent to different locations when it's not needed or not in demand. And then finally, the transportation grid is where we could save a significant amount of energy producing products if we know exactly what we need and we can meet the transportation needs of a community in a way that moves away from fossil fuels or independent vehicle usage. So, these plans or these suggestions to make our buildings more efficient, to make our vehicles more efficient, come from programs like Energy Star, programs that are federally funded that are going to set specific standards for things like fuel efficiency. So the corporate average fuel economy, or CAF standards, are set by the federal government in conjunction with the EPA, but there's also a lot of other federal groups that are involved. And this is an example of one of these practices that is going to increase fuel efficiency for vehicles. We're seeing a push on a state level in some cases, such as California, to move towards vehicles that don't use fossil fuels and instead use electric vehicles or hybrid vehicles. And so there's a lot of, push to make sure that these changes happening at the federal level and at the state level. Energy surveys of houses, like you guys are going to do, reveal where we can save in a building specific location. And this is true for things like schools and businesses as well. So how can we change how we've insulated our buildings? How can we change how much heat transfer there is through our windows? How can we stop heating and cooling losses to hold heat in when we need it and release heat when we don't need it, to make sure that we're not retaining energy or losing energy when we don't want to be? How do we heat our water? So water heaters are, one of the most energy consuming objects in the house. So how can we make that sort of a more efficient process? And the same is true for lights and other appliances that we have. So when you do your survey of your house, you'll start to see, okay, which appliances are the most energy intensive? What sort of lighting do you have? What is your heat transfer like? How do you insulate your home? What is your heating bill? These are questions that are worth asking and answering to become more efficient, but also to save your family money and to, reduce the carbon output for your family and reduce your overall carbon footprint. And we've seen a lot of changes over the last 20 to 30 years. So here we have a house in 1983 comparatively to a house closer to today. This is a 2012. And now we have things like programmable thermostats. We have more efficient lighting. We have a system of air ducts and insulation that is energy rated. We have different window pane material to minimize heat loss. Yeah, there's just a lot of practices that we do now to be more energy efficient, and this is something that we certainly need to improve. So consider having these conversations with your family and seeing how you guys as a group can actually be more efficient, save yourselves some money, and have a positive impact on the environment. Overall, the economy kind of needs a rehaul. If we want to improve our energy efficiency, we need to start moving towards a mixture of renewable energy and non-renewables. Right now, we don't have the system in place and we don't have the economy in place to completely eliminate fossil fuels, but we're moving towards it. We really need a more sustainable, cyclical economy. And so there are, things that we can do on a grand scale to make sure that that is the case. And so we have a lot more complicated system than we think. Part of the complication of that system is the general power grid and the infrastructure of the power grid. We have a hugely centralized macro power system right now, where only a few energy companies, which are sort of, quasi publicly owned companies, control where the power goes, how it's traveling, who gets access to it, etc. The local company that we're talking about here in California, where we live, is PG&E. But companies like this exist all over the country, where you have a centralized power plant, and from that central point, you need to send all of the generated power out to where it needs to go. It is produced and dispersed from a central location to the outside. Now, if each of those outside locations, each of those small scale locations could generate their own power, less pressure would be put on the grid, and that would eliminate the amount of waste heat that's produced basically as we're transporting that power from the central area across the grid. So this is one thing to think about when we think about, okay, how can we on a nationwide scale or a statewide scale become more efficient? We need to overhaul our energy infrastructure. Other ways that we're going to be more efficient are to make sure that we are doing what we can to find alternative sources for the same functions. So if your goal is to heat your building, we generally have a really nice resource every day that allows us to heat our buildings passively. Passive solar is a huge push right now from architects to building managers, etc., who are trying to redesign buildings so that most of the heat comes from the sun and solar radiation and doesn't actually need any heat generating power. So we can make sure that there is a well-insulated structure with proper materials that absorbs the heat that's coming into the building and retains that. If you're trying to do cooling instead of using energy to generate a air conditioning system, you would want to have a number of overhangs and proper ventilation to passively cool the home. And this is great. All of these changes that you can make to your home that can do this give you tons of net energy because you're not actually expending any to get the work done. In some homes and in some places, we're moving towards active solar heating systems where a little bit of energy is required, but essentially we do capture that solar energy into some sort of central heat-absorbing fluid, and that fluid can then be pumped around the home. It can be stored, it can heat water, it can do a lot of different things. It's better for net energy because you are using the sun as the source of that heat instead of getting it off the grid. So it is useful, but it does require a little bit of active pumping to move that heated liquid throughout the house to do the heating that you want to do. Other types of solar include concentrated solar, and so the images that you see here are concentrated solar power, where they collect or concentrate the incoming solar energy using a series of mirrors. So here you have a huge field of mirrors that all are pointing to a central location, and that central location is going to basically be able to absorb that energy. Here we have a trough system where, again, it's sort of curved, and it will sort of point the sunlight that it's reflecting to this liquid that's moving through this central rod. And so these concentrated solar projects are meant to bend the light or reflect the light to boil water or some other type of fluid, which can then be heated and produce steam to generate electricity. Concentrated solar is a little bit different than photovoltaic solar cells. So these are going to be cells that convert solar energy directly to electricity. And you've all seen these types of solar cells. They're found on something as simple as your calculator, right? Where you have solar cells that are found right there, and they're going to be the ones that are powering your calculator. And if we expand that on a large scale, we're able to, when exposed to the sunlight, excite the electrons, capture those excited electrons, use them and send them to the grid to power things or to generate electricity. It's nice to have these devices because you can make pretty much, you can power something pretty much anywhere as long as you have access to sunlight. It can be on a single individual device. It could be on an individual house. It could be a large array. It's really flexible in sort of how we use those things. So overall, solar is moderately good yield, moderately limited CO2 emissions. There's some emissions that are associated with the extraction and the production and the manufacturing for the materials in these products. But for the most part, there's less CO2 emitted comparatively to our non-renewables. And because of the ease, especially for the PV cells and where they can be, it's really easy to install and move, and the prices are coming down, and it's really competitively priced at the moment. Now, the drawbacks, of course, are that we need access to the sun. And when you don't have access to the sun, or when you're over-generating electricity comparatively to your usage, you need some sort of storage or backup system. So these areas need to come with a battery system in order to be able to store that energy for later use or for use at night. We see a high cost for older solar systems, but we're getting better, and those prices are coming down. And then for these large-scale arrays like this concentrated solar one, there can be disruption to the ecosystems in which you're placing them. Hydropower is going to involve the use of water to, again, spin a turbine to generate electricity. And this uses sort of the kinetic energy that's associated with the flow of water or the fall of water to indirectly produce directly produce electricity. This is an indirect solar energy. And what do I mean by that? I mean that the hydrologic system is powered by our sun. The evaporation of water, the precipitation out, all of those things are solar powered in nature. And so this is an indirect use of solar energy. When that water is released, it's going to eventually flow back towards sea level before being evaporated back up. And we can capture that flow, we can use that flow to help us. Waves that are generated, if you're using sort of wave and ocean generated power, is also coming indirectly from the sun as well. So we know about this one. We've seen this when we looked at water diversion. We build a dam, we allow some of the water to flow through a controlled section of that dam. As it flows through, it spins, generates electricity on the turbine, which then gets sent to the grid. But we know that there's a lot of downsides associated with hydropower, especially the big dam systems. There's displacements of people, there's land disturbance, there's disruption to the ecosystems. We're moving now towards these micro hydropower generators. This is an example of one where you basically get an offshoot of water from the river, allow it to move down, and then send that water back out into the river once it goes through its turbine. And this is great. So it's going to, spin a rotor blade using the same water that you would normally use in a large-scale dam. And it can be placed in any stream or river with very, very minimal disruption. We also have some wave capture systems that are compressing air and allowing that to spin a turbine. We're seeing underwater buoy systems that have turbines that spin as ocean currents, waves, tides, etc. move by. And so there are some coastal hydropower systems coming online that could be useful. And I think this is a source that we'll start to see used more and more as we go into the future. Wind is another indirect form of solar energy, and it's used to generate power pretty well. It's the second fastest growing producer of power in the world behind solar. We have both offshore wind farms and wind farms on land. And in much the same way as our water power generation, the spinning of a wind turbine is going to generate power. And this is great, especially in areas where we have lots of wind and we want to be able to generate a lot of energy. When wind travels over water, for example, the fetch is so big that the wind picks up, nothing's there to block it, and it can blow very strongly for a very long time, and we can capture that energy at incremental speeds. So we get a high net energy yield. Wind's available pretty much everywhere. There's not a lot of places where there's no wind. It lowers the cost of electricity in that location. Almost no CO2 emissions with the exception of the production of the wind turbines. But again, much like with solar, if the wind does stop, we need to have a backup system with either stored energy in a battery or grid system or something to accommodate or to make up the difference. There's a lot of NIMBY associated with wind power. A lot of people say, no, I don't want it near me because it blocks my view or something like that. People who live close to wind turbines do report there is a level of noise pollution, and some conservationists describe bird strikes as a big no-no associated with these guys. We're growing a lot of our fuels. Even the cars that you drive run on at least 10% ethanol vehicles right now. So that ethanol comes from corn that we grow here, mostly in the United States. But there's a lot of resources that we grow that can be used as fuel. Why is that the case? Well, our traditional non-renewable fuels are hydrocarbon-based, and guess what we're growing? We're growing hydrocarbons. So we can continue to use leftover crop residues. We can even use animal manure. We can chop and use fuel wood. There's a lot of biomass that's available to us to simply burn. And much of the world's population relies on biomass to generate the heat that they need and the cooking that they need to do. So a lot of people throughout the world still rely on biomass as their primary source of energy. And that has been the case for hundreds of thousands of years. in an effort to replace fossil fuels, we're shifting how we use biomass and now refining it to create liquid biofuels. Biodiesel is one example, and you can see the biodiesel cycle here, where we extract oils from our crops, we refine those oils into a material that's usable, and then we burn the very well refined material in our vehicles or some such thing. It does produce CO2, but that CO2 is, being used to grow more crops in the future. So there is somewhat of a cycle here that makes it more efficient than just fossil fuels. And the same is true for ethanol, right? When we grow our plants, we can harvest the sugars from those plants, refine them to make ethanol, distribute ethanol. In some cases, ethanol can be used as a fuel. We use about 10% ethanol in our gasoline, but there are some countries, and we'll see an example of this when we look at Brazil, that have flex fuel vehicles that are able to burn 100% ethanol if they need to, if they don't have access to a cheaper gas. Again, when you burn those things, CO2 is produced, but the idea is that the CO2 goes right back into the growth of more plants. So it's not a perfect system, but it is a renewable one. And we're starting to see just sort of more and more biofuel usage from this case. I've shown sort of classic crops here, but some of the biofuel systems that we're starting to see involve the use of algae, and using algae to grow large amounts of primary producer material, refine that, and use that. So we're starting to see other organisms besides classic crops being used for this project. Geothermal is great. I think everyone should be involved with geothermal energy. Heat stored in the soil and under rocks, and warm water that is in our mantle that is heated by Earth's systems has great potential for supplying areas with both heat and electricity. So it's almost a cogeneration in itself, and a very natural one. So usually what will happen in this case is we will have a pump system that pumps water down, and underground that water will start to be heated. As it is being heated, we pump it back up, and we're able to warm our homes. And the same can be true for cooling the house. The ground itself tends to stay cooler than the amount of heat that we see in the summer at the surface. So we can pump, warm volume down, and we can bring back cooler volume. And so we lose energy to the ground, which is super useful. In some countries where hydrothermal activity is at the surface, this is going to be a little bit easier to access hydrothermal reservoirs. And the example that I have here is from Iceland, where they're actually using hot water that's already being heated by the earth to spin turbines and generate electricity for themselves. Not everywhere in the world can do that. There's some hot spots that can do that, like Iceland and Hawaii, some places that are more geologically active, like New Zealand might be able to do that, or the African Rift Valley. But for the most part, anyone in the world can do geothermal, but not everyone in the world can do hydrothermal. So that's sort of the main difference when we start thinking about these energy resources. Finally, the last one I'm going to talk about is hydrogen. Hydrogen is the simplest and most abundant chemical element in the universe, and hydrogen fuel cells can be used to generate electricity. So if you have access to hydrogen gas and oxygen, which we have a lot of, we can produce electricity and water vapor. This is great. We're allowed to produce the energy that we want, and we don't have any fossil fuel waste to do it. In theory, hydrogen should be the source of energy of the future. It's a very simple thing that we can do. We could recreate this process in class if we wanted even. But the challenge is finding that hydrogen gas. There's not much here in Earth's atmosphere. And so right now, in order to produce these energy generating systems, we have to make hydrogen gas. And to do that, we need other sources of energy. So in total, it right now gives us a poor net energy yield until we find a way to generate that hydrogen gas that's a little bit more efficient. The technology for this is still fairly expensive, but we are seeing prototypes for hydrogen vehicles start to come onto the market, which is really exciting. And yeah, this is just one tech to start to pay attention to over the next 25 to 50 years for sure.